will be a quick review of our significant figures. I'm going to start by giving you a few little basic rules on that. First of all, significant figures, the numbers between 1 through 9 are always significant, right? The numbers that come between significant figures are always significant, okay? Where we get into some trouble is when we hit zeros. So I'm going to give you some cases and examples in which zeros would be significant. If they come in between significant figures, they would be significant, such as 101. This 0 appears between the ones. It is significant, so this would have 3 significant digits. Excuse my cat. If they are the last digit after a decimal, they are significant, such as 0.0010. This 0 is the last digit after a decimal. It is significant. So this number would have 2 significant digits. If the 0 happens to have a bar over it, it is significant, such as 100. As it's written here, would look like it has 1 significant digit. But when I put a bar over that 0, that now makes it have 2 significant digits. If a 0 has a decimal only after it, that 0 would be significant, such as the number 10. As it says here, this number has 1 significant digit. But when I put a decimal only after that 0, now this number has 2 significant digits. So looking at the class examples, if you will underline the leftmost significant digit, which is a 4 because it's a digit between 1 and 9, and the rightmost significant digit is a 3 because it's a digit between 1 and 9, and you count what you've underlined and everything between 1, 2, 3, 4, 5. This one has 5 significant digits. Example B, the leftmost significant digit is a 4. This 0 here is the last digit after a decimal, so you underline it, and you count what you've underlined and everything in between, so this has 1, 2, 3 significant digits. Hopefully this is coming back to you as a review. Looking at C, the leftmost significant digit is a 4, and the rightmost is a 3. These zeros in front here would not count. This 0 is not between significant digits. It's not the last digit after a decimal. It doesn't have a bar over it, and it doesn't have a decimal only after it. So looking at this would be 1, 2, 3, 4. 4 significant digits. Looking at D, this only has 1 significant digit. These zeros here do not fall under any of the circumstances up top. And then for E, you have the leftmost is the 4, and then of course this last digit after a decimal. So this one would have 2. Okay. Let's look at rounding each of the following to 3 significant digits. You start with your leftmost and count out 1, 2, 3. So you're going to write 3, 1. Now when you go to write the last digit, you need to look to the right of it. If the number is 5 or higher, you can round up, and in this case 5 is 5 or greater, so that would make the 2 become a 3. Looking at this one, 1, 2, 3. So it's going to be 1, 3, 1. This 2, because there's a 5 to the right of it, would round up to a 3. And then you can put zeros as placeholders for the rest of them. Okay. Looking at this one, 1, 2, 3, 0.313. We would not put in zeros here. We want 3 significant digits. If you did put in zeros here, that would end up making it have 5, and we only want 3. This one has 1, 2, 3, 0.00313. these zeros are not significant, so we cannot count them as part of the 1, 2, 3 that the question asked for. All right, looking at calculations with significant digits. Move this up. All right, when adding and subtracting, you use the lowest number of decimals. So looking at this number here, you get 3 plus 6. You punch that into your calculator, or hopefully you would not need to, but you get 9.0. Now, the reason why it's 9.0 is this has one place past the decimal, and this one has 2 places past the decimal, and you need to use the lowest number past the decimal, so we would have to stick with the 1. 15 minus 3.7, come up with 11.3, but this 15 has no places past the decimal, and this has 1 place. The lowest then would be 0 places, so this should be written as 11, reflecting 0 places past the decimal. When multiplying and dividing, you use the lowest number of total significant digits. So when you say 3 times 6 and you get 18, this whole number here has 2 significant digits and this one has 3. So your answer should only have 2 significant digits. So that would be 18. If you do 42 divided by 7.21, what you get in your calculator is 5.82524, etc. This one has 2 significant digits, this one has 3, so your answer only needs 2 because you're going to go with the lowest number of total significant digits. So the correct answer would just be 5.8. And of course, this bottom thing is just saying that exact numbers have an unlimited number of significant digits, and so do counting numbers. So we really wouldn't look at them in terms of looking at them for significant digits when doing a calculation. I hope you find this helpful. If you need any more help, please come see me.